Today, we're going to talk about how we can make our cities cooler. Because, as most of you might know, we are facing big challenges with our cities overheating today. And today, we're going to look at how actually we can solve this. And there are good examples of this that we're going to go through. But the first aspect that we're going to talk about today is that our modern cities today are overheating. And basically, people are moving out of cities, literally, because they're getting too warm. They're not comfortable anymore to live in. And actually, a lot of people are dying because of the heat waves that cities are facing today. So let's address this together. Let's understand the problem. Why is this happening? There are a couple of reasons of this. And if we look at how modern cities are designed today, we basically have a lot of high-rise building everywhere. And these buildings are, in the majority of the cases, built with concrete and glass. And so what happens is that as the temperatures are rising around the world, and the more and more buildings we're building, what happens is that when the summer comes and the sun is shining, is that the heat from the sun hits these buildings. And concrete and glass, what they do is that they reflect the heat. So what happens is that they reflect the heat and they keep reflecting the heat, and eventually our cities, the streets, are becoming extremely hot, beyond temperatures that are comfortable. So this is one of the main reasons, because our buildings are not designed to absorb this heat. Instead, they're designed to reflect it because of the kind of materials we're using. And then another aspect of it is that, we used to have, before we built modern cities, used to have a lot of green areas. And green areas actually are able to absorb the heat. So what they do is that when the sun is shining on them, they don't reflect it back to the street. So we need green areas because they help to absorb the heat and keep the cities cooler. And another interesting aspect that most people don't think about, what is happening is in coastal cities, for example, where we are in Malaga, where we have the sea, the ancient people would avoid building high-rise buildings at the coast. And actually, they were not really building high-rise building. But if we look at it from above, if we look at a map from a city that has coastal line, like this, having the ocean there. So the way the urban planners back in the days used to design the city was that they were aware how important the breeze, the wind from the sea and the ocean was, because they would bring cool temperatures. So when they were designing their buildings, their cities, they would make sure that all the streets are open. So if these are streets, no? And then we have a lot of buildings like this. This is looking at from above, right? So they would always make sure that, and this being the streets, that they would allow the wind, coming from the ocean to be able to pass through the streets and keep the streets cool. This was one of the fundamental layouts in urban design. Now what happened is that as we evolved, as we became more and more dependent on conventional heating systems like air conditioning, we lost this knowledge. We lost the knowledge of designing our cities to take advantage of nature, how nature cools the city. So what happened was that because we have AC now, there's no need, that's what people thought, to cool our buildings, to cool our cities naturally. So what happened, and because economy, we started to build a lot of buildings right at the coast because these buildings were basically had a higher value. You could sell them for much more. And basically, then what we do when we do this is that we're basically building a big blockage for the wind. So all of this just becomes almost like a big wall that doesn't allow the wind to come into the cities. So when the breeze from the city is trying to come from the ocean to here, it just gets stops. It just gets stopped there. And what happens is that everything behind it, all the urban areas behind it, gets overheated. And this, right now, today, we're reaching temperatures like 45 degrees or even more. And literally, people die out of these temperatures because you have the aspect. So there's three aspects. You have the aspect that you're walking, in the city here, you're getting overheated by all the reflection that's coming from the building. There's no natural world anymore because we've basically removed it in the majority of the cities. And the breeze, which is trying to come from the ocean now, which is here, is trying to come, it cannot reach you anymore because we have built all these coastal buildings like these one, no? Because they sell very good. They're the luxurious apartments that everyone wants to live in. But the problem is they're blocking the wind. The wind is not able to come and cool the city. So because we're building our cities so fast without thinking about all of this, our cities are basically not comfortable anymore. So it's becoming a big problem. And we need to find solutions of solving this. And there are actually, interesting enough, very interesting solutions that has been proven to work in cities. And to understand this, we're going to look at a city in Iran called Yazd, which is a city that is designed for heat. This city itself has temperatures up to 47 Celsius degrees, and that's almost 117 Fahrenheit. So Yazd is a city that's designed for, that has proven how cities can stay cool. So what is very amazing with Yazd is that all of this is done with nature-based solutions. This city has been there for thousands of years and the system still works today. You can still go and visit this city and you can see how amazingly they've been able to cool their city. And one of the most famous thing that this city has is what is called cooling towers or wind towers, wind catchers. In Farsi, they are called badgir. So how they work is that around the city there are big towers which are not where people live, but they're actually towers that are cooling the city. So in the days, actually, if you look at their buildings, this is also very interesting, is that most of their buildings were actually designed with arched shapes. They wouldn't do flat roof. And you want to know why? Because this kind of shapes absorbs way less heat, right? So a flat roof is that most of our buildings are built today, absorbs a lot of heat and makes the building really, really warm. A dome-shaped roof like this actually absorbs almost 35% less of the heat, just the way it can reflect just because of the geometry, it can reflect more and absorb less. So what they would do, that's one aspect of it, is the shape of the building itself. Then the second aspect is that they would have these cooling towers where hot air would blow into them. So, and they would build them higher up because the higher you go, the cooler is the breeze. So they understood these basic principles. And in the very, very top of these towers, they were openings. So there were openings that could basically allow the wind to get in here, okay? And there's many different ways of how this technology can be used, but one of the most simple ways of explaining it is that they would basically bring this hot air through these towers and channel them down. And then under the ground, they would have basically cooling tunnels. So they would dig tunnels, and many times actually, they would go pretty low, and they would go as low that they would almost hit the groundwater. So as you might know, underneath the ground, there is water. So they would go and they would come to a level where the groundwater is. And when the air then comes through here, it starts getting cooled naturally. And obviously, these were also connected to all the houses. So this was a whole infrastructure of cooling system. It's so impressive, and it's when you really get into it, you're going to be blown away how amazing this system works. So when the air comes here, you know, the lower you go under the ground, the cooler the temperature gets. So when it's really at the coolest points, they were able to get these temperatures so low that they were actually, and then this is how the air goes in here. And then they would actually use this system to create ice in the desert that almost gets 50 degrees Celsius. So the city of Yazd is a proven example, and this system works still today without maintenance. This is the amazing things with this system. So it's a combination of using materials, natural materials like adobe that can basically help and cool the buildings. And basically by understanding the cycle of the wind and understanding physics and integrating that into the urban design. So that way, they would even create pathways also through their cities that would have this breeze. So even the walkways throughout the city would be cooled down like this. So Yazd is a proven example that cities can be cooled down if we plan them well. Now, this is what we call passive cooling. And this is what we just looked at. But if we go into and look in a little bit more in detail as well, how this can be done how passive cooling can be done in another way is also very interesting because cities also need water, right? So these ancient people were so clever that they combined the need of having water with cooling their cities because they go hand in hand. So it's important to understand this. So what they would do is they would build, this is another way passive cooling worked, is that they would build these dome structures that were not necessarily for people living. And from above, you would see a nice, beautiful dome. But what you wouldn't see is that under the ground, they would dig almost 12 meters down sometimes. And these dome structures were actually water reservoirs. So they would collect rainwater, for example, when it rained, and they would store the water under the ground, and then they would combine this with the cooling towers. So they would add cooling towers to these structures. So not only just for the city, and then the same way, they would catch the wind, get them through these openings in the cooling towers, and the hot wind would basically come through there and go through there. And then it would travel down the wind, and as it came down here, what would happen here is super interesting. Because this wind, when it comes in here, it's not super cool, but what happens is that when it passes through here, something very interesting happens. Because, see, my friends, underneath the ground, in a desert climate like this, there's a lot of cool temperatures. So all around this water is cool temperatures because you go underneath the earth, it's cool. So this water would stay cool. And when you bring warmer heat to it, what would happen is that the heat, the energy from this warm wind would basically get in contact with this cool water. So you're combining hot and cold. So when the water passes through here, there would be evaporation happening. So when this evaporation happens, this air here becomes cool. So then it passes over from being hot to cool. And then what they would do is that they would channel that air and they would catch that air. And then they would reuse that air for their buildings. So if they had a home, so this is a dome where people live, they would bring this in to their buildings, to their commercial areas. So now that wind goes through here. And so what's genius about this is that they've built a water reservoir, which is storing water for the city. And at the same time, they're using the same system to cool the air, to cool their buildings naturally. And then, obviously, because back in the days, there was no pumps, what they would do is that they would also create an axis, an underground axis, where basically they had a structure here, and then there was a staircase where basically people would be able to go down here and access this water. So down here, there was a tap where people could come and they could get cool water in the desert. Can you imagine that? So there was a tap here. So people would basically, if they wanted to have cool water, and they would actually build these in their commercial areas around the city because it was a hot city. So they thought, how do we provide cool spaces for our citizens, and how do we provide cool water? So people, would come here, and they would be able to go down here, and from here, they would be able to drink and access cool water and cool themselves down. So this is another way that passive cooling works. in ancient cities, and we have so much to learn out of these. And the thing is that it's very clear that these systems are better than our modern cities, because our modern cities are built and designed to rely on air conditioning system, but that's only cooling the buildings. Now, in warm climates, like Southern Europe, for example, we consume about 80% of the energy of a building to keep it cool. And so that's one aspect of it, that it's our modern cooling system are consuming a lot of energy. And the second aspect of it is that it's not reliable. It only works when there's energy. So if there's any blackout that happens to our cities, our buildings will overheat. And this way of cooling our buildings doesn't rely on the electricity that our cities provide. Even if there's a blackout, this is physics. Physics will always work. You cannot argue with physics. And the third aspect of it is that physics doesn't cost money. But using conventional mechanical systems that are consuming energy constantly cost a lot of money. So not only is it sustainable, but it's actually way more affordable and way more reliant. So what we can apply today to our modern cities is that, okay, maybe some cities don't want their cities to look like this, but they can still look modern, they can still look like modern cities do, but underneath, we can still use the same concept, we can still use, because in a lot of cities, we are developing high-rise buildings today because we have the technology of it. But how can we apply passive cooling systems? Well, once again, it's all about the urban design of it. So if we are going to continue building high-rise buildings in our cities, there are a couple of aspects that we need to have in mind. One thing is that we cannot just keep putting our buildings so close to each other. We need to do the basics of keeping some distance between our buildings, right? So if we do that, we're able to integrate green areas, which are fundamental for our well-being as well. So, it's not just asphalt and concrete that keeps us absorbing it, but there's actually green areas that help us to absorb the heat. Now, this should be, a regulation that, we just need to make sure that we are including the natural world in our designs. Then, when it comes to the passive cooling system, even though we're doing high-rise building, we can still do these cooling towers. We can still build cooling towers, just like the ancient people did. And we can channel this and bring these to our high-rise buildings. So the same way as the ancient people did, we can simulate this today, so we can actually, predict the outcome of it. And we can bring this cool air underneath the ground, and then we can bring it up in all the different floors of the building and distribute that. So with some simple engineering, even high-rise buildings could apply this solution. And as well, as we're doing this, we need to also have in mind that it just is not sustainable to build so much buildings in front of the coast, because we're blocking the breeze from bringing it into the city. So by combining these solutions from the ancient cities and with modern technology and materials, because we have a better advantage today. We have a technology, we have sensors, now we have artificial intelligence. We can really refine this knowledge that we forgot, you know? So it's not just about trying to reinvent new solutions. We also need to look back to the past, what has worked. There are cities out there that are ancient and that are being completely cooled naturally. So why are we not looking at those solutions that are proven and bringing this back into our cities? And this, my friend, is exactly what we are teaching in the Biotonomy Academy. So we've developed a program where you can learn about how to integrate nature-based solutions like these into architecture and construction projects, both on a building level, but also on an urban level. So if you believe, just like we do, that the future of our cities need to be more nature inclusive, then join our online academy program and learn how to start implementing this in your own projects.